Today is the continuation of same chapter, light. We were doing the topic refraction. Last time I showed refraction is bending of light from one medium to another medium when light travels. Refraction occurs where? At the surface separating the two medium. What is the cause of refraction? Change in the speed of light causes refraction. When the ray of light travels from rarer to the denser medium, it bends towards the normal, and when it travels from denser to the rarer medium, it bends away from the normal. Last time I showed the angle of incidence, angle of refraction, normal. Normal is the line perpendicular to the surface, line which is making 90-degree angle to the surface. Angle of incidence, angle of refraction, we always measure with the normal line, normal. Okay, we did those kind of things last time. And now a situation is there like this. We are having two mediums, maybe a rarer medium here, maybe a denser medium here. Ray of light, suppose coming like this way. This is called, the incident ray is passing normally through the surface. This is the surface separating the rarer medium and denser medium. The ray of light is passing normally through the surface. Normal is perpendicularly through the surface. Then what will happen? This time the ray will not bend. This is the case when the ray travels from one medium to the another medium, yet it does not bend. This is also possible. No refraction that is taking place. When the ray passes the surface normally separating two media like this, that time the ray of light will go straight without bending. There also the angle will be 90 degree. And this time the angle of I will be equal to 0 degree. Don't say 90 degree. Because angle you are taking with the normal. This is coming along the normal lines. When the what angle does it make with the same normal? One line is making what angle with itself? Answer is 0 degree. Let's see that I value 0 degree here and R value 0 degree we write here. This is called normally incident ray. Normally incident ray. When the ray passes the surface normally, in that case the ray does not bend. This is the only exceptional case. That time the angle of I will not be 90 degree, rather it will be 0 degree, and angle R also will be 0 degree. Both angles will be equal, that means no bending will take place. Only in the case when the ray of light passes normally through a surface separating two media. Media is the plural form of medium. Two media like rarer and denser media. When it passes normally, that time the ray of light does not bend, rather it goes straight without bending. Okay, now you have to learn effects of refraction, or the recent test question based on refraction. Effects of refraction of light. Refraction of light. Some diagrams will learn effects of refraction of light. The diagram number 1 will be bending of a stick underwater. We'll have a stick which is immersed in water obliquely like this, slanting way, not exactly like this. When you immerse a stick obliquely in water, you will find the entire stick, the portion in the water will appear bent. So, what is the cause behind? Say the cause is diffraction of light. We'll draw a diagram and show the bending of a stick underwater. So for that, the diagram will be this. We'll be drawing the diagram. This is water. And we are having a stick like this. This part is P, this part is Q. Now, this was the actual stick. So now from here the ray of light, the observer is in the rarer medium of here and wanting to see this one stick underwater. From here the ray of light will be traveling like this. It will bend away from the normal like this. In the same lines we will draw a dotted line here like this. Here. Here is P dash. The image will be formed. This part will be seen somewhere here. And the image will be formed here like this. This point will be marked as P dash. Here is the actual point P, but its image is formed here at P dash. So here is the observer. Observer is seeing from this point. He will find the stick is this portion of the stick till here is straight, but from this part it is looking bent or it is looking crooked. The stick will not be appearing straight throughout. So we will draw this diagram to show the bending of a stick under water. Same way, this is the diagram would be important. Another one is, suppose we have second one, we are having an empty glass. There is a glass which contains a coin like this. There is any object or whatever, maybe a coin is there. This coin is just invisible from a point. From this point, from here, the view of this coin is just hidden like this. Observer is here and he cannot see the coin in the glass. This glass is not transparent, it is opaque, so person out here at a particular level cannot see. What should he do so that he is able to see the coin? What answer will he give? The answer is that we have to fill the glass with water completely. You will be filling it with water completely, okay, not partially but completely like this. Fill it with water. Fill it with water. So here is the point, suppose P. Then from here the ray of light will travel like this till here is straight. Now the ray will be bending away out here. Now this point will be seen somewhere here. Okay, this point, that image of this will be formed here like this. This point P will be appearing raised out here. This is the actual position and this is called apparent position. Apparent position. That is, the object will appear to be raised from its actual position. Then the person will be able to see for the person, the position of the coin will appear raised. It will be appearing to be somewhere here where from this point the person can see it easily. And this is the effect of refraction. This is the use of refraction of light. You will make use of the refraction of light to see the object clearly if you cannot see it from a particular point. Position of the object will be appearing raised due to refraction effect. This thing will happen when the ray of light is traveling from one medium to the another medium. The position of the object will appear to be raised due to refraction effect. The another consequence is same thing happens here. Formation of twilight. What is called twilight? The evening hour in the we still receive sunlight for quite some time, though the sun will be already setting in the horizon, but we are still able to see the sun for some time. Then the sun, after that there will be darkness. The light which we have between the evening and the night, that light is called twilight. 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 Formation of twilight is also due to refraction effect. So here is the ground, what here? Ground is here. Here is the sun. Below the horizon, here is the observer. That means the view is hidden. but the ray will be traveling like this from the sun, will travel due to atmospheric level, will travel like this, because here is the denser medium, this is rarer medium. The ray of light is bending towards the normal. Sun's image will be seen somewhere here. Sun position will appear to be raised. Sun's position will appear to be raised somewhere here. This is the image. Image of sun. Image of sun will be seen over here. That means sun's position will appear to be raised by this amount. And this sun will be giving light on the surface of the earth, that we call twilight. Twilight. This is the cause of formation of twilight. If question asks you draw a diagram to show the formation of twilight, we draw this one and name the phenomenon of light responsible for bending of the stick or responsible for this effect or this effect. The answer is the bottom of the tank filled with water appears shallow than its actual depth. Reason is the same. All are reason type question based on this fact, because the object's position will appear to be raised due to refraction effect. Then the question comes like this: a person's leg underwater will appear to be shorter. That means the entire leg underwater will appear to be shorter. What is the reason? The reason is the same, refraction. The position will appear to be raised, and the apparent depth, there will be real depth, there will be apparent depth. So apparent depth will be less than the actual depth, so the person's leg will appear shorter. The cause of twinkling of the star is also refraction, but there are many refraction, successive refraction, a number of refraction taking place in the atmospheric layer. In the atmosphere, we got layers of the air, and the ray of light traveling from rarer to denser like this. The density of air keeps on changing, so it follows a zigzag path like this, and that we call twinkling effect. The twinkling effect is also due to diffraction of light. So all these phenomena are caused due to refraction of light, bending of when we are having a glass block and we keep it over a piece of paper, the print in the glass block appears to be raised. That is also due to refraction of light. Now you can give next heading: refraction of light through a glass block. Refraction of light through a glass slab or glass block, like this. There is a rectangular glass block. We are having a glass block like this. And we show the refraction of light through the glass block. Ray of light is traveling like this. This is the incident ray. Here we are having a normal. This angle is called angle of incidence. So how to draw the diagram? To draw the diagram, this ray is traveling from, this is air, this is glass. The ray will air to glass, and the air to denser, it will bend towards the normal like this. This angle is R. Now here is another. This is glass. This side also air. This is also air. The glass where the ray will bend away from the normal. How to complete the diagram? So this ray will be going away. It will not bend towards the normal, rather it will go away from the normal. This side, it will go anywhere this side. So to draw that one, first this line will be extended straight in the forward direction by using ruler like this. Dotted line. This line will be put forward. Dotted line. That's imaginary line. So now this ray will be drawn in such a way that this ray and this ray should look like parallel to one another. You know the meaning of parallel. This line and this line is looking somewhat parallel like this. Like this and like this. These two lines never look like parallel. They don't draw like this. So from here we draw the line so that it looks like almost parallel. If not exactly, but at least it should approximately look like parallel. Like this line should look like parallel to one another. This angle is called E, angle of emergence. We write the level that this is incident ray. This is incident number 1, number 2, number 3. We write 1 is incident ray, number 1 is incident ray, this is the level or various number. 2 is refracted ray. Refracted ray. Number 3 is emergent ray, the ray which is finally coming on. Emergent ray. Emergent ray. Angle I is angle of incidence, we call angle of incidence. R is angle of refraction. And E is angle of emergence. Emergence. These two angles are always equal. We write angle I is angle E. They will be equal. Angle of incidence and angle of emergence will be always equal. And the reason is because the medium is same. Here to glass, here also we are having glass to here. Pair of media is same. As long as the pair of media is same, the angle will be equal. If this is I, this is R, this is R, so this will be also R being alternate angle, so this also will be same angle. Then angle I and angle E will be equal. If this side is air and this side is water, then they will not be equal. Then that time I and E will not be equal. Otherwise they will be. Generally they are equal. Two rays are always parallel to one another. Incident ray and the emergent ray are parallel. That also we have to write. Incident ray and emergent ray are parallel to one another. Why they are parallel to one another? Because they are contained by two parallel sides. This side and this side are parallel. That's why this way and this way are also parallel or always parallel, because they are contained by two parallel sides. Here the distance, perpendicular distance between these two rays, the incident ray and this ray, that is called lateral displacement. This distance is called lateral displacement. Lateral displacement. This distance is called lateral displacement. This gap, this distance is called lateral displacement. The shortest distance or the perpendicular distance between the incident ray produced and the emergent ray is called lateral displacement. Okay, now another situation. Suppose we are having a glass block here, but the ray of light is coming like this. It has been making 90-degree angle. Now in this case, what will happen? In this case, the ray will go straight without bending. Here also it will go straight without bending like this. What is the value of I then? I value will be 0 degree, not 90 degree. Always remember, whenever you see the angle 90 degree, the angle of incidence is 0 degree, because the ray of light is coming along the normal. The ray of light will go straight. In each ray must have arrow. Here are shown the arrows. Arrows are very important. You must mark the arrow. No arrow, no marks. This time the ray will go straight without bending, because this is passing the surface normally. That is the situation. So today's lesson is this much. Next day we will be doing the refraction of light through a glass prism. Today we will glass slab and next day we will be doing a glass prism. So thank you very much.